Hi, today I'm talking about LeetCode problem 1347, minimum number of steps to make two strings an anagram. What this problem asks you to do is write a function that takes two strings, s and t, and returns the minimum number of steps that are needed to make s and t an anagram. Now, in a step, what you can do is you can pick any letter in s and you can change it to be whatever other character you want. Now, an anagram, recall, is simply any two strings that you can rearrange to be exactly identical to each other. And so you can, rearrange them into any order you want. Another way of thinking about it might be it's two strings that are equal when the order doesn't matter, when you don't care about the order. So AAB is an anagram of BAA because you can, reorder them. We could move B to the end like this. And so what we need to do is say, okay, we're given two strings that maybe aren't an anagram. And what would we need to do to make them equal? So one of the examples they give is, like in this case, S and T, what I need to do is just change my C to an A. And now they'll be equal. And so one of the examples they give is, what if you had the string friend and the string family? How many changes would you need to make? So I would just say, well, let's go through it. And let's say, like, for F, yep, we have an F in family there. For A, no, we don't have an A, so we're going to need to do one change and change the R to an A. We've used one change so far. M, no, we don't have an M, so should we change the I? No, because we want to use the I later. There's an E here that we could change to M. So, okay, we've used two changes. I, we have it, I is right there. L, we need an L, so let's change this in to an L. We've used three changes. Y, we need a Y, let's change the D to a Y. And that would be four changes. And if we look at their example for friend and family, we see that, yeah, they expect the output of 4. And so we also agree that we need 4 changes. So, kind of thinking about this, it's easy enough to approach the solution that way for a string of size 5, or a string of length 5. But it would be a lot harder if we were looking at strings of length 50,000. So, like another thing to think about is, what if, friend and family had an F at the end? Or like, what if there were two characters? So we couldn't just say, like, do I have an F? Yeah, I have one, but have I already used that one? It's like more complicated logic. So we're not just saying, like, is this string in S or is this string in T? We're saying, is there an unused version of this character in S? And yeah, like, we don't want to be making a contains check and keeping track of whether we've used the letter or not. Like that just seems very, very slow and complex and kind of fragile logic. So instead, what we want to do is we want to convert the strings into a frequency table. So remember when I was talking about what an anagram is, I was saying it's like two strings are equal if the order doesn't matter. Two strings equal, order doesn't matter. So like we can think about that as just like the frequency table. Do they have the same numbers of letters? So if we want to convert family F and friend F, what we do is we just count, well, how many letters do you have? You have two Fs. One A, one M, one I, whatever. We count the same thing up for friend F, and we know how many letters you have. And then what we do is we find the differences. So we look at all the keys that the two have in common. So like we take, the set of keys here that they have in common, and we just say, how many letters do you have different? So for F, they have no differences. They each have two Fs. For A, they have one difference because there's an A in family and there's no A in friend F. For M, they have one difference. There's an M in family, and so on. And what we get is, well, there's 0. They have the same number of I's. They have one difference for L. They have one difference for Y. They have one difference for, I can't read my own handwriting here, whatever letter this is supposed to be. I guess it's an E. Yeah, sorry, I can't read my own handwriting there. I don't know what letter I meant that to be. But they have one letter for E, one difference for N, and one difference for D. So these are the characters different. And recall that our operation, our step, will change one letter into any other that we want. So whenever we execute an operation, we're basically going to be reducing the difference by 2. Because we'll say, oh, okay, like one string has one more A and one string has one more M. Well, I guess we'll just change an A to an M, and we'll cancel out 2 differences simultaneously. So in other words, what we do is we just take the sum of these values, of their differences, and we divide it by 2, because we can, cancel out 2 differences with one operation. And so we get our result 4, which is exactly what they expect for the input of friend and family. They want an output of 4. So let's implement that logic in code in this function min steps. And so what it's going to do, what I did the first time when I wrote this is I just wrote my own counter function. I thought, if I were doing this in a job interview, I probably wouldn't use kind of Python's default library to solve things. I might mention it, but I'd probably write it out myself just because I want the interviewer to know, if he's asking me this question, if the interviewer is asking me this question, they want to see if I can implement, kind of basic logic myself. So I'd avoid using the default constructions that would solve this, even though they're going to be more performant, which is why I wound up using them, just to see how fast it could go. So my count function just says, here's a dictionary for the letter in my string. What I'm going to do is say, in my result dictionary, set it equal to the value of getting the letter from my result dictionary. And if the letter isn't in my result dictionary, I'm going to use the default value of 0, and I'm going to add 1 to that. Then I'm just going to return my result dictionary. So this is just a way to convert a string into a kind of frequency table or a count, where the keys are each letter in S, and the values are the number of times that letter occurs in S. And counter does the exact same thing, but it's going to be faster, and it's a built-in logic of Python. So I get my 2 counters, and then I'm going to find the difference between the 2 counters, and I'm going to get the values of that difference, and then sum those values. So this step here in line 21 would be equivalent to this, where we sum the values in our differences dictionary, and then just divide it by 2. So let's look at the differences function here on line 12. It's just going to take a 1 and a 2. These are both dictionaries that are going to be given to it. And we have this result dictionary here. For k, n, and what this is on line 14 here, this is the union set operator. So what it's going to do is take 2 sequences and return the result of their union. So it will give us all of the unique keys that these 2 things have in common. It's basically getting the set of the keys. So it would be equal to like a set of this union set of T keys. It's just kind of a concise way to write it. So for k in this kind of union set, what we're going to do is say result sub k is equal to the absolute value of the difference between the 2. And so, like, you might think you need to use the get operation here. I wondered that myself. because what if, k isn't in t? And the answer to that is just for Python's counter dictionary. It works kind of like a default dictionary. Well, I shouldn't say that, but just in practice it seems to. If you try to access a key that's not there, so not there, you just get the value 0. So it works kind of exactly the way you want it to if you're trying to access a value that's not there. Yeah, so that's in my result, and I'm going to return the result. And yeah, that's how I support the logic that solves the problem. The test cases I wrote, I lost them. I must have navigated away from this. The test cases I wrote, I used their examples. I tried one, string of length 1. What if, all the letters are the same? What if there's only one letter different? What if all the letters are different? I tried all those test cases. And I should have tried a length 50,000 test case, but I just didn't bother because I knew this was going to be pretty performant anyway, in that it is, it's running an O of n time. It's just converting strings to a dictionary and then taking a difference between those dictionaries. So it's linear time, so I knew we wouldn't really need to bother with the worst case scenario. And so I've just been trying to think, how would I make it even faster? And one thought occurred to me while I was explaining it. I wonder if it's faster to use dictionary composition here. O of k less t k for k in O keys t keys. I wonder if it's just, I don't even know that this is going to be faster. But sometimes it seems to me that composition using a list or dictionary composition is faster. We'll see. Hard to say. Hard to say if that's a random fluctuation, because a difference of only 4 milliseconds. Hard to say if that's a random fluctuation or if it was marginally faster. I wonder if I even need to say keys. Although I don't think that would do anything for speed. Yeah, I think it is a random fluctuation. But, we're kind of right at 90 percentile for speed. Anyway, that'll do it for me. If you like this video, let me know by clicking the like button, say something in the comments. If you want to follow along, I'm trying to solve a LeetCode problem a day, something like that. So go ahead and subscribe if you want to see my explanations. Thanks for your time. Bye-bye.